Om Shri Sai Ram. Dear children, last class we have started with functional groups and we have learned some of the functional groups, especially allo-alkane, alcohols and aldehydes. Today we are going to continue with the functional groups. Before that, we are going to look at some of the assignments. Draw the structure of the following compounds. First I gave bromopentane. Bromopentane, which is the functional group present in bromopentane, Br, that is it is a allo-alkane compound where bromopentane you have to write the structure. First you have to write the pentane structure. Any one of the hydrogen atom can be replaced by bromine atoms. Next, second I gave hexanal. Nal means it is a aldehyde, good. Then the structure is hexanal. I said last has to be the functional groups for aldehydes. Next I gave octanol. Nol, ol means it is an alcohol. The functional group here it is an alcohol. Last hydrogen atom has to replace it with OH group, that is hydroxy group. Next, identify the functional groups from the above compounds. You can easily identify from bromopentane. Bromo is an halogen group where Br is the functional group. Hexanal, it is an aldehyde where CHO. Next, octanol, it is an alcohol hydroxy group, that is OH is the functional group. Let us continue these functional groups today's class. Today's class we are going to discuss about carboxylic acid and ketone, and we are going to discuss homologous series. Let us know what is carboxylic acid. Very important this topic. Today's class we are going to learn about carboxylic acid. What is carboxylic acid? Very important definition here. Compounds containing COOH as functional groups are called as carboxylic acid. Here functional group is COOH. Very important. For carboxylic acid, how can we identify the carboxylic acid compounds? Is nothing but functional group, it contains COOH. Compounds containing COOH as functional groups are called as carboxylic acid. Next, they are represented by general formula RCOOH. R is nothing but alkyl or aryl group. The functional group of carboxylic acid is represented by RC double bond OH. You have to remember this. This is the functional group. How can we write functional group of COOH? You have to write like this. This is very important. Next, the name carries the suffix is -ic. For carboxylic acids always ends with -ic. Hexanoic acid, pentanoic acid, butanoic acid means the suffix always ends with -ic acid. Pentanoic, butanoic. If it ends with OIC, then it is carboxylic acid. Let us look at some of the examples. We know we'll take general example, that is, let us write the structure of butane. You know the structure of butane. Next, yeah, very important. See, when the last carbon atom is replaced by functional group COOH, then it becomes 1-butanoic acid. Similarly, in the case of aldehydes, where last atom is replaced by CHO group. Similarly, in carboxylic acid, last carbon atom has been replaced with functional group COOH. Then it becomes 1-butanoic acid. This is the structure. C double bond OH. See this structure. Let us draw some of the examples. Propanoic acid. Propanoic. First you write the structure of propane, or just we know the propanoic means 3 carbon atoms. But last carbon atom has to replace it with carboxylic group, that is functional group COOH. See here. This is the structure of propanoic acid. That one propanoic acid means last carbon atom is replaced with the functional group. Second one for hexanoic acid. Hexa means 6. I will write here. This is the structure of hexanoic acid. That is one hexanoic acid. Last carbon atom as replaced by the functional group COOH. Then it becomes hexanoic acid. Similarly, in the same aldehydes and carboxylic acid where last carbon atom has been replaced by functional groups. Let us draw the structure of pentanoic acid. Draw the structure of pentanoic acid quickly. Pentanoic acid. Draw the structure of pentanoic acid. Please draw the structure of pentanoic acid. Yes, good. Last carbon atom as replaced by functional group. It becomes pentanoic acid. This is a pentanoic acid. Next, write the structure for acetic acid or methanoic acid. Draw the structure for acetic acid or its common name acetic acid. Its common name is acetic acid. Its IUPAC name is methanoic acid. Methanoic acid or acetic acid. Draw the structure. This is the structure of acetic acid. So, not methanoic, sorry, it is ethanoic acids. Common name is acetic acid. Its IUPAC name is ethanoic acid. Methanoic acid is methanoic acid. It is ethanoic acid. This structure you can write. This is very important. This acetic acid, methanoic acid, this is the structure of methanoic acid, this is the structure of acetic acid. Similarly, you can draw octanoic acid, hexanoic acid. Similarly, you can draw structures. This is for, you have to remember carboxylic acid functional, carboxylic acid means COOH group as functional group. Second point you have to remember, last always ends with ic, OIC, ic. methanoic, pentanoic, like that last suffix will ends with ic acids. Then we can easily, they may ask one question, identify the functional group present in methanoic acid. They may give structure or they may tell in the wordings. Then you can tell it's the functional group as identified as carboxylic acid, and you can write COOH group. This is about carboxylic acids. Next, let us learn last functional group, that is ketones. It's very easy. There will be confusion in ketones and aldehydes. Please concentrate properly here. What are ketones? Compounds containing C double bond O. This is the functional group. Very important. C double bond O or keto group. This is also known as keto group. As the functional group are called ketones. Ketones means C double bond O. Next, they are always represented by R C double bond O by R, means that is R nothing but alkyl or aryl groups. Next, the functional group of ketones is represented like here. Please see here. This is the way we have to represent the functional group of ketones. Next, suffix always ends with -one. Example, butanone, pentanone, hexanone, propanone. None means always ends with -one. Butanone, like that it ends, always ends with -one. Next, let us look at the example of ketone. Let us write the structure of butane. We already know the structure of butane. Next, when the hydrogen atoms on last but one, means last but one is replaced, these two hydrogen atoms are replaced by keto group, that is double bond O, where C is always there, is replaced by the double bond O, then it forms butanone. This is the structure of butanone. See here, this is the structure. Last but one carbon atom, see here, last but one, here two hydrogen atoms are there. These two hydrogen atoms has been replaced by keto group. Then it becomes butanone. See here, this is the structure of butanone. Let us draw the structures for propanone, pentanone and heptanone. Propanone. Last but one has to replace it by keto group. This is the structure of propanone. Next, pentanone. Pentanone, see here. Last but one has to replace it by functional group. This is the structure of pentanone. See the structure 1, 2, 3, 4, 5. Last but one as replaced by the functional group. Hydrogen atoms is replaced by the keto group. Then it becomes pentanone. Next, draw the structures for heptanone. Draw. One, two, three, four, five, six, seven carbons. Last but one has to replace it by functional group. This is the structure where hydrogen atoms are. Similarly, draw the structure for butanone. Please draw the structure for butanone, children. Similarly, write first what but 4 carbon, last one you have to replace by keto group, then you have to write, then you have to fill hydrogen atoms. That is very easy structures for to draw. Please draw the structure of butanone. This is the structure of heptanone. Draw the structure of butanone. Butanone. Yes. Good. This is the structure of butanone. Similarly, you can practice the structures. For your 10th class, we have learned some of the functional groups. Let us quickly revise. First, we have learnt about haloalkane, where halogen atoms like bromine, chlorine, fluorine, iodine as the functional groups. Second, we have learnt about alcohols. The hydroxy group, OH group, is a functional group in alcohols. And we have learnt about aldehydes, CHO, that is the functional groups for aldehydes. For carboxylic acids, what is the functional group? S, C, double bond O, OH, COOH is the functional groups for carboxylic acids. And similarly, what is the functional group of ketones? C double bond O is the functional groups for ketones. And there will be one more functional group, that is amines. Amines you are going to learn in your first few C classes for 10th up to ketones is the syllabus. Let us have general look for carboxylic acid. General formula RCOOH. What is the functional group? Good children, COOH suffix ends with ic. Butanoic, pentanoic, hexanoic acid, like that always ends with ic. You can identify either by name, you can identify the functional groups, or through the functional groups you can identify it belongs to aldehydes, or it belongs to carboxylic acids, or it belongs to keto group. Either by name or by what functional groups we can easily identify. Next, suffix over IUPAC name: butanoic acid, pentanoic acid, hexanoic acid. Next, similar structure. Always last carbon atom has to replace it by functional groups for carboxylic acid. Next, for ketone, what is the central formula? R, C double bond O, R dash, means R here represented by alkyl or aryl groups. Next, what is the functional group? C double bond O is the functional group, suffix ends with one. Butanone, pentanone, hexanone. Next, one of the structures, that is the propanone. Next, here last but one hydrogen atoms as replaced by keto group, C double bond O group. Then you can easily write the structures. This is the overall functional groups that we have learnt. Let us go for homologous series. Very simple. What are homologous series? Very simple. Please look here. A family of organic compounds with same general formula, similar chemical properties, and successive members differing by CH2 units. Let us will look at into one of the example. See here. What is the structure for, write the structure for methane, CH4, ethane, C2, H6. Let us look at into alkanes. See brothers, CH4 and C2H6 are differing by what units? CH2 units. See here. Ethane and propane are differing by which unit? CH2 units. Similarly, these two, propane and butane, are differ by which, how many, which, that is differing by CH2 units. Means you have to understand here, if a family of organic compounds with same general formula for alkanes, general formula is CnH2n plus 2, good. Similar chemical properties, most of them are having similar chemical properties, but very important, the successive members methane, ethane are differing by CH2 units, propane and butane are differing by CH2 units, means successive members differing by CH2 units are called as homologous series. Means you have to remember, same general formula, similar chemical properties, but the successive members ethane, methane, propane, butane, pentane, ethane and ethane has been differing by CH2 units. Similarly, in case of propane and butane, they are differing by, the successive members are differing by CH2 units. Such compounds are known as homologous series. This is a general example. You have to remember that simple thing, you have to remember the successive members differing by CH2 units. Next, characteristics of homologous series, similar properties varies in a regular and predictable manner. Next, similar chemical properties shown by the members of a given series. In a given in alkane series, they are similar in the chemical properties. Next, gradually varying physical properties along the series, means some of the physical properties may vary. Ethane, methane, propane, butane, some of the physical properties can vary from ethane to methane, methane to propane, so like that it varies. Next, the formulae of members in a series fit in the general molecular formulas. They have same general molecule in a series. For alkane, they have a same general formula. That is, what is the general formula for alkane? CnH2n. For alkene, what is the general formula? Cn. For alkane, general formula is good, CnH2n plus 2. For alkene, what is the general formula? CnH2n. What is the general formula for alkyne? CnH2n minus 2. Good children, you are very alert. Next, examples. I said methane, what is the structure of CH6? Ethane, they differ by CH2 ends. Ethane, propane, they are differing by CH2 ends. Such compounds are known as homologous series. Homologous series means you have to remember same general formula, similar in their chemical properties, but they are differing by which units? CH2 unit. Next, let us look at one of the example for homologous series. Let us go for alcohols. Can anybody tell what is the formula for methanol? What is the formula for ethanol? If there is any difference between these two compounds, yes, they have been differing by which unit? CH2 units. Even what is the then for ethanol and propanol, what is the difference? They are differing by CH2 units. This is a simple example. If see, same functional group, similar in the chemical properties, but the successive members have been differing by CH2 units. Such compounds are nothing but they are known as homologous series. Like that, you can draw for the structures for you can also draw for carboxylic acids. For also you can also draw for ketone, aldehydes. You can draw homologous series. For today's class, I have some of the assignments. Please do these assignments today only. If you have any doubts, we can clarify in the next class. Write the structures for pentanone. Means pentanone. What is the functional group of pentanone? Good, ketone. Ketone group. Ethanoic acid means it is carboxylic acid. Good. Ethanoic acid. I already draw the structure of ethanoic acid. That is which functional group? Carboxylic acid. Good children. If you know the functional group, then easily you can write the structures. For carboxylic acid, last carbon as functional group. Last but one for ketone group, where last but one hydrogen atom just to replace it by O, that is double bond O, that for ketones. Next, what is homologous series? You know what is homologous series. Explain with an example. Take any one of the alkane series, then you can explain, or for alcohols, you take the series of 4, then you can explain. They are differing by what units, all you can explain. Similar chemical properties but same general formula, but they are differing in CH2 units. For today's class, we have completed the functional groups and homologous series. Next class, we are going to learn about the chemical properties of carbon. So, we conclude today's class. Sai Ram.